Hello, and welcome to TrainSignal. I'm Don Jones, and this is the Modifying Data lesson in the Database Administration Fundamentals course. In this lesson, we'll be covering the various ways that you can modify data in your database tables, including the Insert Into command, the Update command, the Delete command, Truncate Table, and Drop Table. Because we're going to be talking about deleting data, we'll also do a quick overview of referential integrity. You were introduced to all of these modification statements in another lesson, but now we're going to be using them against a real database. So as we go, we'll also cover a variety of additional gotchas and tips and techniques that make using these more efficient and effective. Now, we've already talked a bit about SQL Server indexes and how those can help speed up querying the database. When we start talking about modifying data, well, we've moved into an area where SQL Server indexes can both help and hurt. If your modification statement contains a where clause to limit the scope of the modification, and many modification statements will contain a where clause, then having the right indexes can speed it up, because those indexes essentially speed up the where clause. But every modification means that the indexes also have to be modified, so having more indexes can slow things down. Consider that as we review the modification queries in detail, and keep it in mind as you think about indexes. So let's start with the Insert Into statement. Here's what it looks like. You begin with the command itself, Insert Into. Then you provide a table name. In parentheses, you provide a comma-separated list of the columns that you want to provide values for. Then you have the keyword values, and in a second set of parentheses, you include all of the values that will go into those columns. Numeric values do not get delimited, as shown here by the value 1. String values, as well as date values, get delimited in single quotation marks. Dates must be provided in a format that SQL Server can recognize, in this case, month, day, year, or day, month, year. You must specify all columns and provide values for them that do not allow a null value and do not provide a default value as part of the table's design. Both of those things are decided when you create the table. You must provide the values in the same order as the column list. However, that column list can be in any order you like. And if a string value contains a single quote, such as the name O'Brien, you must double it. That single quotation mark thing can be a little confusing, so let's look at it in much bigger detail. Here we've got the name O'Brien, which we want to contain within single quotation marks. If we just allowed the single quote between the O and the B, then it would look to SQL as if only the O was quoted and the Brian was just hanging off there by itself. So we double the single quote whenever we mean a literal single quote or apostrophe. So we've got the outermost single quotes actually delimiting the contents of the string. This is the quote or apostrophe in the name O'Brien. And this is the extra one, and it escapes the quote that follows. In other words, SQL Server will see those two as a single, literal, single quote or apostrophe. Making sure that single quotes are properly escaped is probably one of the most important parts of protecting against SQL injection attacks, which we discussed in a previous lesson. Many programming libraries have got utilities that do this for you, so you just have to tell them to escape a particular string, such as user input, and they'll handle it. Values that are fed to the parameters of a stored procedure don't need to be escaped because the entire value is actually treated as a single unit, and so it doesn't need to be delimited at all, and that's another advantage of using stored procedures. Let's go into SQL Server Management Studio and start playing a little bit with the Insert Into command. For this example, I'm going to use my test database rather than AdventureWorks so that I don't have to worry about messing up my sample data. I've expanded the test database so I can see the two tables I've created, people and products, as well as the 3 columns in people and the 2 columns in product. I'll open a new query window. make sure that it is focused on my test database, and it is. So let's go ahead and write an insert query. Insert into, my table name in this case will be people, and I'm going to insert values for the ID and name columns. That would be a comma separated list. And the values I'll provide will be 1, and then we'll come up with a name, Don. Execute that query. Excellent. Now, normally I would maybe quickly check that with a select query just to make sure it worked, but just so you can kind of see this visually, let's select the top 1,000 rows, and you can see that 1 and Don were inserted. Address contains a null value because I did not provide a value for it. Let's leave this up here and do it again. We'll insert value. Well, actually, you know what? Let's this time just insert a name and an address. So there's our name. Because address is potentially a keyword, I'm going to put it in square brackets. That way the color coding looks correct to me. And let's run this. We got an error, and it said it cannot insert the value null into the column ID because the column does not allow nulls, so the insert failed. We can actually see that over here. It says that the ID column contains an integer and has the not null constraint applied to it. So that's what happens if you don't provide a value for a column that requires a value but does not provide a default value. Next up is the update command, and this modifies one or more columns of one or more existing rows. Typically, this is used with a where clause to limit the rows that are updated. For example, update, and then the table name, and then the keyword set. What follows next is a comma-separated list of column and value pairs. So column equals new value, comma, column equals new value. You can update as many columns as you want to in that fashion. If you don't want to change every single row in your database, which you usually won't want to do, then you will include a where clause and provide some criteria to limit the scope of the update. Now, when you write that where clause, sometimes you may want it to only look for rows that contain a null value in some column. For example, I want to update my database and I want to find all the rows that have a null in a particular column, and I want to put some meaningful value into it. Null is a special value that means not set. It is different from 0 or an empty string or other empty values. You can check for a null in a where clause by using the special phrase is null. You cannot compare null using a normal comparison operator. In other words, as shown in the last bullet here, you couldn't say where join date equals null, because the result of any normal comparison to null is null, not true or false. And so that's why you have to use the is null, as shown in this example. Update the customers table. Set the join date column equal to 1 January 1999, where the join date column is null. Let's go into SQL Server Management Studio and play around with the update command. We'll continue working with the test table, and let's write an update query. Update people, set, and let's see, let's set the ID equal to 5 and the name equal to Bobby. I don't want this command to update every single row in the table. I only want to change those where the name is already equal to Don. And that where clause can be as complex as you want to. Use as many different comparisons as you need. Execute. One row affected. Now that's kind of an important thing to look for when you run a query. I'll show you why. Let's run it again. This time, 0 are affected. There's no error message, but nothing met my query criteria anymore, and so no changes were made. Let's quickly query everything out of here in the graphical grid so you can see that the ID was changed to 5 and the name was changed to Bobby. Address is still null. Let's take care of that. Let's set address equal to the word unset, where address is null. And again, because SQL Server is color coding address, it means it potentially sees that as a special keyword. So I want to enclose it in square brackets just to make sure that it doesn't do anything unusual. We'll run that. One row affected. Let's query these results back out. And now we can see that address has been changed to the word unset. Unset doesn't have any special meaning to SQL Server. It's not like null. Unset is just a word I put in there because it has some meaning to me as a person. Next up is delete. This removes entire rows from the database, or from a table, typically only those rows specified in a where clause. Now, because it removes an entire row, you don't need to specify any columns. You just say delete from, and then the table name. If you leave it there, then it'll delete every row from the table. So that's why you typically include a where clause, where some column equals some value. Remember, if you leave out that where clause, you are deleting everything. There's no are you sure, and there's no undo button. If your intent is to delete every row in a table, and you might want to do that from time to time, delete with no where clause can take a long time against a very large table, and that's because it has to delete every single row one at a time. If you intend to empty out a table completely, then the truncate table command can be faster. This deletes everything much faster than delete would do so, but there is no ability to be selective. In other words, there's no where clause. You just run truncate table and then give it the table name. There's no are you sure, and there's no undo button, so you'd better be sure. This also frees up space in the table structure for faster reuse by SQL Server. It is not super instantaneous. This is not something you want to do during a major production spike in traffic, because the act of freeing up the space actually can take SQL Server a little while to perform. So this is something you need to use judiciously, because there will be a performance impact. You might also consider the drop table command. This is DDL, not DML, and it completely removes not only the data from the table, but it also removes the table definition itself. It deletes the entire table. You run it by simply running drop table and give it a table name. Again, there's no are you sure, and there's certainly no undo button. People used to do this when they wanted to clear an entire table, because dropping it and then recreating the empty table was faster than using a delete. However, although it does take a little while to free up that free space, truncate table is a faster and smarter way to clear out a table while leaving it in place for future use. Now, we're not going to play around with all of those options, but let's go into SQL Server Management Studio and play around with the delete statement. Now let's write a delete query. Anytime I sit down to do this, I tend to make a little bit of a mistake. I'll say delete all from people. And I think I do this because the syntax is so similar to the select query, where select star from people would be perfectly legitimate. But you'll notice that SQL Server's not happy about it. It's got the little red squiggly underneath the star, and that's because in a delete statement, you never need to provide a column list. You're deleting the entire row, so the column list is unnecessary. I am not going to include a where clause, and this should delete everything from my table. One row affected. Let's query the results, and it is now an empty table. So that's how delete works. It's not all that complicated, but you do need to use it with some discretion, because you don't want to accidentally wipe out the contents of a table unless you really mean to. I did so in a previous lesson, but I want to call your attention once again to the formatting that I'm using. SQL Server allows a query to break across several lines. It uses the syntax to determine when the query is actually at an end. Other relational database management systems often require a semicolon to signal the end of a query, but SQL Server doesn't in the case of a simple single query. It does permit the semicolon if you're used to that syntax from another system and want to keep using it. Once again, the SQL Server command syntax isn't case sensitive, but string comparisons can be case sensitive and often are in the default installation. Uppercase hello is not the same as lowercase hello. However, as I've mentioned before in previous lessons, that can be different depending on the server's installation configuration. So if you're not sure if a particular server is being case sensitive or not on those string comparisons, then you should run a quick query to check so that you know exactly what you're dealing with. Now let's quickly talk about something called referential integrity. Because tables can relate to one another, referential integrity is very important when making changes to data. There are a variety of ways in which a database designer can enforce referential integrity. One is called a cascading delete. They might also set the table up to deny deletes, and there are other approaches. The whole idea behind referential integrity is to prevent orphan rows in dependent tables. So what's an orphan row? Well, here's three tables in a database: the customers table, the orders table, and the orders items table. You've seen these before, and they're all related to one another. The orders table has a cust ID column, which takes its values from the customers table's cust ID column. The order items table has an ID column, which takes its values from the orders table's ID column. So these things all relate to one another. If I delete a customer, let's say customer ID 41, I've left an orphan row in the orders table. The orders table is now referring to a customer ID, number 41, that doesn't exist. I can't just go in and delete that because it would also leave an orphan in the order items table. It has an order ID 100 that would no longer exist. So I've created an orphan, and I could create a second orphan if I wasn't careful. So how do database developers and database designers deal with this? Well, one way is to simply deny the delete. In other words, the table structure can be created in such a way that if I try to delete the row from the customers table first, SQL Server will detect the dependencies or the potential orphans in the orders table, and it will prevent that delete from happening. The only way I would be able to delete that is if I started working backwards. If I were to delete the row in order items first, then delete the row in orders, and then delete the row in customers, so that I'm getting rid of the orphans before they become orphans. Another approach is to use a cascading delete. So I delete the customers table row, and SQL Server automatically goes through and deletes the potential orphans for me. And that's something that, again, can be set up as part of the table's initial design. When an operation needs to contain several distinct tasks, such as deleting those dependent rows so that you can eventually delete a parent row, you may want to ensure that all of those happen as a single atomic operation. In other words, you want to ensure that either all of the rows get deleted from all those tables, or none of them get deleted. That way there's no chance whatsoever of the operation being partially completed. SQL Server permits this through the use of something called transactions. When you declare the start of a transaction, SQL Server sort of saves up all the different tasks that you then perform. When you're finished, you can commit the transaction, and that makes everything a permanent change, or you can roll back the transaction, undoing all of the tasks that had been created or performed as part of that transaction. For example, let's say that we do decide to delete that row, and that we've set it up so we then go delete the other two rows that were dependent on it. These are shown in green because I want to stress that these are actually part of a transaction. I've told SQL Server to delete them, and it's remembering that I want to do that, and it's sort of pretending that they've been deleted, but they've not really been deleted yet. Once I've removed all three of those rows, I can tell SQL Server to commit the transaction, and the deletes become permanent at that point. In this lesson, we covered the major ways that you modify data in a SQL Server table. We looked at the insert into statement or command, update, delete, truncate table, drop table, and we had a brief overview of referential integrity and transactions.